In today's webinar, we're going to talk about seed quality, what it is, how to measure it, why it's important. We're also going to talk about seed labels and specifically the lab report of analysis, or simply the lab report. Today's presentation will run about 45-50 minutes, and we'll have about 10 minutes afterwards for questions. We just wanted to remind you we've added one webinar. I'm getting a little background noise. If you could all turn your mics off, please, that would be helpful. Thank you. Just to remind you, we added one webinar in May on seeding calculations. Monica's going to give that one. This presentation is going to be recorded and posted to the Montana NRCS and Plant Materials websites. And remember, you can always reach out to Monica or I with questions, or to the Montana Seed Growers Association for seed certification questions, and to the Montana Department of Ag for seed labeling questions. So, you know, to get started, in all fairness, NRCS field staff are often, they have limited oversight or control of seed-related issues. That said, seed quality is extremely important, and helping landowners is really going to be quite valuable. So this webinar is one of 6 in a series describing the entire seeding process. And for optimum success, users should reference the other webinars as well as noted references and other sources of information. The webinar series is really designed to be used as a unit, and important information in one webinar may be needed to fully understand the information in the others. Over the course of the training today, we'll try to convey the things we've learned, provide useful practical advice, and to especially note problem areas. That is, things you may never have thought about without specific experience. Before we get started, I think it's important to note that seed is highly variable, from species to species, lot to lot, year to year. Some species have inherently low germination. Montana four-wing saltbush comes to mind. Some, like the needle grasses, have long awns. The uniqueness of each species and seed lot can sometimes result in unavoidable quality issues. An example would be seeds with long awns may require intense seed processing or cleaning to remove the awns so that the seeds flow well in a drill or blend well in a mix. Unfortunately, high amounts of processing can cause some seed damage. So it simply helps to be aware that there are these differences and limitations when seeking to buy the best seed lot possible. So what I'm saying is sometimes we may have to compromise a little bit. So what constitutes seed quality is somewhat subjective, but these are some of the common attributes of high quality seed. Obviously, it is what it says it is. It's true to type. It helps if it has a performance pedigree. It's a cultivar, it's a pre-varietal release. It has some testing behind it that makes it perform better and is therefore by default higher quality. The two conventional measures of seed quality are purity, and that it has high purity, has limited amounts of other stuff in it, and it has high germination or high viability. We also like low dormancy in seed. It's not really a seed quality issue, and sometimes it's unavoidable. Seed just have an inherently strong dormancy mechanism. We're going to talk about this. But if the seed doesn't have a normal inherent dormancy mechanism and a method of overcoming it, we prefer that it doesn't have dormancy. And then certified. I can't stress how important buying certified seed is. And if you can avoid common or VNS, variety not stated seed, that's really going to help with the quality of the seed and the quality of the of stand establishment. So seed lots vary widely in quality. The key to procuring the best quality seed is to look at the information on the seed label. Or better yet, have a seed lab report. If seed is being purchased without a label or current lab report, you may be setting yourself up for failure. Seed from reputable seed dealers always carries a current label. The law requires that each lot of seed offered for sale must be truthfully labeled. And this applies to a single species, a seed mixture, and whether the seed is certified or non-certified or common. Seed testing protocols are developed and managed by the Association of Official Seed Analysts, or AOSA, AOSA. Each seed producing state has an official seed testing lab and follows the AOSA protocols. So this shouldn't be confused with AOSCA, and that's the Association of Official Seed Certifying Agencies, who assist clients with various subjects related to seed certification rules. And then there's the Federal Seed Act, and that provides regulation of seed that is sold and shipped from state to state, and state seed laws that regulate seed sold within a state. We're going to be talking more about that in a bit. So the two major factors, the two conventional major factors that determine seed quality are purity and viability of the seed being purchased. So purity is the actual amount of pure seed of the species in the lot, the target crop. This is determined in the seed lab by weighing out a sample and physically separating the pure seed from the inert matter, weighing it and determining the percentage of the sample that is pure seed, as well as the percentage of inert material, other crop seed, and weed seed. And obviously, the higher the purity percentage, the better. Some native grasses may only have purities of 50 to 60% due to awns or other seed appendages, things like that. Coated or prilled seed may have very low levels of purity because the coating is considered part of the inert material. So you shouldn't be alarmed if you're buying something like Garrison creeping foxtail. That's a really light, fluffy seed. They often coat it so it flows better in the drill, and it has a really low purity value. That's not an issue. You just have to be aware of it. Seed that has a lot of trash in it, and that could be inert matter or other things, can be difficult to run through a seed drill, and we definitely don't want to plant any more weed seed than necessary. So high purity is a good thing. Okay, germination and viability. So the terms germination and viability are sometimes used interchangeably, but they define different things. Percent germination describes seeds that, when given proper environmental conditions for growth, temperature and water, things like that, they germinate and produce a radicle and hypocotyl in a normal seedling. Seed labs use the same standardized procedures nationwide that are species specific. So that's where those AOSA protocols come in. The actual germination you see in the field is likely to be lower than the germination because the germination in a lab is ideal and our field situations are not. Viability or total viability describes seeds that are alive, but all may not germinate immediately. Viability includes germination, but may also include seeds that are dormant or hard or won't germinate. Hard seed is seed that is alive, but does not germinate during the germination test because it can't imbibe water due to a hard seed coat. But it doesn't necessarily mean it's dormant. Dormant seed is also alive, but does not germinate during the germination test for various reasons. And many native species have seed dormancy mechanisms that prevent germination under ideal environmental conditions until something has happened to overcome that dormancy. Seed dormancy is Mother Nature's way of hedging her bets, of having live seed available over time and over a variety of environmental conditions to ensure perpetuation of the species. The tetrazolium test is used to determine the viability of hard and dormant seed and is also used in place of germination tests for many native species that require lengthy dormancy breaking pre-treatments. A TZ test indicates that the seed is alive, the embryo is alive. It shows up as stained material. There's a lot of training that's important for folks that use this technique. It's really easy to have a false positive or a false negative, but it basically just says that the seed is alive. It doesn't say that it'll germinate. So here are just a couple of images from the Montana Seed Lab that Bridget Westfall sent me. The one on the left shows some flax, and those you can see are nice, healthy seedlings. They measure the length of the radicle and the hypocotyl, and it has to reach a certain length to be considered a fully germinated seedling. On the right are images of chickpea that have been stained with tetrazolium, and it shows various things. In fact, the seed on the left has a little damage. You can see it right here. It's stained a little bit differently than the rest of the seedling. You and I would never know that, but folks that have training in this area do. So that's a tetrazolium test, and it indicates if the seed is healthy and viable, but not that it will necessarily germinate. Seed quality. So seed dormancy here is defined as viable seed that would fail to germinate given normal environmental conditions that are favorable for growth. Some of those things are things like after-ripening of seed. I'm going to talk about that here a bit. Hard seed coats, seed that's quiescent or asleep. And there are numerous cultural treatments that are used to overcome seed dormancy. I lump seed dormancy in with seed quality because sometimes it's a factor when seed quality is questioned. So it's common for some species to have a short-term dormancy after initial harvesting. A rule of thumb might be that species that need a period of maturation, or we call this after-ripening, require about 6 months on the shelf in storage to fully mature. So these are two lab reports of the same lot of prior slender wheatgrass. So the one on the left, in the red circle, we see that this test was actually taken shortly after the seed was harvested. We can look at the seed lot, and it shows that the seed lot was harvested in 2010, and the test occurred in early 2011, and germination was 57%, and dormant seed was 38%, and we had a total of 95% viable seed. In late 2012, so it's almost 2 years later, same lot, another test shows that, it's a little hard to see here, 95% of the seed germinated. We had no dormant seed, and the total viability was again 95%. That's just after ripening of the seed on the shelf. Why is this important? You can't expect that seed to germinate on a freshly harvested lot in year one sometimes. So when you're picking out lots that may be ideal, you may want to avoid ones that are freshly harvested, if you can tell, and that have dormant seed. Just these are more FYI. We use different types of techniques to overcome hard-seededness. Normally, it's mechanical scarification. We have machines that will actually scarify seed. This is a picture of honey locust. on the left that was soaked in water. Seed looks exactly the way I put it in the water. The one on the right, you can see it's starting to swell. That seed was scarified. It will imbibe water, either start a dormancy breaking treatment, or it will actually germinate depending on the species. So this is common for things like Sicer milk vetch. It has to be scarified to get good germination. We can also use acid to scarify a seed, and there are certain species that this is really essential to do. Kinnikinnick or bearberry is one of those species. But it's really quite dangerous. It's messy. You have residual. Generally, we avoid this if possible. But it is one of the techniques that is used. Now, for a lot of species, we need what's called a cold moist chilling to overcome dormancy. And in our agency, the way we do that is we would recommend a dormant fall seeding. Now, there are many, many different types of seed dormancy that can be overcome by many different techniques. And those techniques usually mimic the niche that the species fills in nature. And so for many species of plants native to northern temperate environments, a cold, moist chilling period of 60 to 150 days overcomes seed dormancy. We're basically mimicking a winter. And we typically accomplish this, as I said, with a dormant fall seeding. Can you spring plant dormant seeds? Sure. You have to consider, though, that over the course of the summer, or over the course of the growing season, that seed is just going to sit there, and you can have insect disease, bird issues, rodent issues, erosion, and other factors that'll consume or cause a loss of that seed. You also have to think about that you're going to have competition when that seed germinates the next year from whatever germinated in year one. So, you know, just keep that in mind when you're developing a seed mix and you're calculating how much seed you want to put in the mix. That could be a factor. So things like green needlegrass, Indian rice grass, many stem wild rye, they actually have a bit of dormancy. So you're going to want to plan that in your seeding mix and in your seeding dates. Many forbs have this kind of a dormancy, and many woody plants. So pure live seed. So NRCS conservation seedings are always based on pure live seed, or PLS. And PLS is just an adjustment to take into consideration the variables of purity and viability with each unique seed lot, so that all seed lots of a species planted achieve the target stand. Given the proper conditions, I'm talking about environmental conditions, PLS is the living seed that is likely to germinate and establish in a planting. So PLS is simply the percent purity multiplied by the percent germination, or TZ viability, divided by 100. So here are two examples to show how PLS is calculated. And at first glance, without doing the calculation, you might not really notice much difference in seed quality. Percent purity is not much different between lot A and lot B, but there is a huge difference in percent germination, which translates into large differences in PLS. So lot B has about half the PLS of lot A. What's that mean? If we're seeding at a PLS rate, you've got to plant about twice as much of lot B to achieve the number of pure live seed as you would in lot A. So to seed the proper amount of viable seed in a planting, it's necessary to calculate a bulk seeding rate based on the percent PLS information on the seed tag. So unless you have 100% pure seed in your test, you're always going to be planting a little bit more than the PLS. There's always a little bit more bulk that has to go into the drill and into the ground to achieve that PLS rate. The recommended PLS seeding rate per acre is divided by the percent PLS of the seed to determine the bulk seeding rate. So in this example, we're going to plant Goldar blue bunch wheatgrass at 8 pounds PLS per acre, and the PLS is 89.56. So 8 pounds PLS divided by 0.8956 equals 8.9 pounds of bulk seed that needed to be applied to achieve a full 8 pounds per acre PLS of the viable seed. It's easy to get confused, but all you need to remember is that the bulk seeding rate is always larger than the recommended PLS seeding rate. PLS can also be used to evaluate and compare seed costs. So simply divide the cost per pound bulk by the percent PLS to determine cost on a PLS basis. So in this example, at first glance, Lot B looks to be the best value at 70 cents per pound bulk, but when you do the PLS calculation, Lot A is a better value, a better buy based on a PLS basis. So it's actually costing you $1.25 per PLS pound with Lot B versus only $1 with Lot A. So most grasses should have germination rates above 80%. That's kind of a rule of thumb, a general rule of thumb. Be cautious buying grass seed with under 60% germination, as it may have lower seedling vigor. Now, don't confuse this issue with seed dormancy. Seed dormancy is a whole nother subject. Source identified grasses, native forbs, and shrubs often have lower germination rates. Germination increases with age. Avoid older seeding lots. There's a little bit of background noise. Could you shut off your mics, please? Some species lose viability rapidly, less than 2 years. For example, winterfat and forage kochia have very short shelf lives. And always refer to current germination tests, and they should be within the last 12 months. So here's some general seed quality issues as they relate to storage. Not everyone buys fresh seed and gets it in the ground in year one. Sometimes it has to be stored. So seed longevity and optimum storage varies by species. Best storage for most species is cool and dry, and we use this thing called the 100 rule, where the temperature in degrees Fahrenheit plus the relative humidity in percent should be less than 100 for good seed storage. So basically cool and dry is best. Rule of thumb, most grasses store well for 6 to 8 years and then begin declining. Hard-seeded species like legumes, things like Sicer milkvetch, for example, they retain good viability even for decades under proper storage. Some species lose viability very rapidly. Winterfat pretty much has a shelf life of 2 years, forage kochia 6 months. So you really want to have a very current germ test on forage kochia. If it's more than 6 months out, you probably have dead seed. And then some species store very well when frozen. We do that for pine and juniper. They deteriorate pretty quickly without storage in a freezer. I think it's important too to not always blame seed quality. You know, seed quality is often used as a default excuse or to mask other causal issues for stand failure. And these are just really a common sense list of some of the things that you might encounter with a failed seeding. Everything from moisture, chemical residue, poor site adaptation, a whole bunch of things. Just remember, it's not always about the seed. Okay, so we're going to kind of shift gears now from seed quality. We're going to talk about seed labels and laboratory report of analysis, or lab reports. So why is the information on a seed label and lab report of analysis important? Okay, so probably the most important factor is allowing the buyer to select high quality seed lots, since all seed lots are not the same. Some information is essential in terms of assembling or building a seed mix as it relates to calculating bulk seed versus pure live seed. Both documents identify and guarantee the species and variety, which of course is important in terms of selecting or verifying species for conservation practices and programs. These documents also provide other important information related to seed dormancy, what other crop and weed seeds are present, and the amount of inert material in the seed lot. All of these factors need to be considered before installing the planting and may be important in terms of assessing planting success or failure after installation. So these are the items traditionally found on a seed tag. And there are about 10 or 12, depending on who generated the tag and in which state, and if it's a federal tag or a state tag. But any of you who have looked at a seed tag recognize a lot of these things. We're going to talk about each one of these in a little bit of detail. So other crop seeds include seeds of species not normally grown for crops and should be shown as the number of seeds per pound of each individual other crop species. So this is basically anything that's not a weed and that's not your target crop. And then weed seeds include the total amount of common and restricted weed seed found in the lot. Restricted noxious weeds are the number of restricted noxious weed seeds by species per pound and are listed separately. So you can actually have legally some restricted noxious weeds in the sample, and that varies from state to state, how many are allowed and if any are allowed. And then you'll have a listing of prohibited noxious weeds, and they are not allowed in any amount in any lot. And you should never see this in a seed report or on a seed label. All seed offered for sale, and as I understand it, even given away, must have a seed label. So a seed label is the document attached to each seed sack. That's the one shown on the left. It contains specific information required by federal and state law. The lab report of analysis, shown on the right, is the report, and it's sometimes called a certificate because it's like a legal document, produced by the seed testing lab with the results of the requested seed tests. So you can get different reports of analysis. Most, but not all of this information also appears on the seed label. We're going to talk about that distinction. So it takes an extra step to request a lab report of analysis, but having it in hand before buying seed can be really important. Okay, so very briefly, seed labeling and testing is so highly regulated that problems are quite unlikely and in fact are rare. But let's just go over a couple of the major points. So seed labeling is governed by both federal and state law. For seed transported across state boundaries, the Federal Seed Act defines what needs to be listed on a seed label. Within a state, most states have their own laws governing seed labels, which typically reflect federal seed law, but often require additional information. Montana rules and laws can be found in the Montana Agricultural Seed and Patented Plant Material and Administrative Rules. The entity responsible for labeling guidelines depends on whether the seed was produced in-state or not, transported in-state or across state boundaries, is certified or common, and other factors. So getting back to seed labels, these are the 10 pieces of information required on every seed label by the Federal Seed Act, which we're going to cover today. With a couple of exceptions, this is the same information you'll find in the lab report of analysis when they contain both purity and germination test results. In Montana, the Department of Ag provides a template for a proper and compliant seed label, which can be downloaded and used as a reference and for the sale of seed. Just want to note that in this label is an alternative dispute resolution statement, which is required by the Montana state law and is a prerequisite for the purchaser prior to filing a legal action should they feel something about the seed lot was not consistent with the seed label. So they have to go through this alternative dispute resolution before filing a lawsuit. So seed tests on the lab report of analysis are regulated by the Association of Official Seed Analysts, AOSA, and are standardized across the U.S. This information is what is printed on the seed label for that lot. Again, the lab report of analysis only contains information on the seed test requested for a specific lot. In this case here, it's the purity and viability information. So again, the lab report of analysis provides much the same information as printed on the seed label, but with some additional detail that is useful prior to purchasing seed. And this is important. It specifies the kind and number of each weed seed and other crop. You're not going to find that on a seed label. Having the lab report in hand prior to buying seed also allows the user to calculate bulk seed values. It makes the distinction between dormant and hard seed, which can influence season of planting and identify the need for pre-treatment of seed, such as scarification. And like the label, it verifies the species, cultivar, or variety, and the class of seed. All of these variables can influence planting success. It's worth noting that since germination tests need to be updated every 6 to 12 months, depending on the class and distribution of seed, an additional lab report will be generated containing only current germ data. And this is what a lab report of analysis looks like when it only reports germination test results. So when you're requesting lab reports from a vendor, make sure to request both the original purity and germ tests and also any follow-up or updated germ tests that have been provided over time. So let's review the major types of information provided on a lab report. Firstly, every report has specific information provided by the sender, and that's in the red rectangle. As to the species, the variety, the lot number, and a lot number could be anything the sender wants it to be. And then if certified seed, additional information related to the class, origin, and certification number. This information should exactly match the information that's found on the corresponding seed label for the lot. So this is the information provided by the sender, but the lab verifies the accuracy of the species and reports that in the purity analysis, and I'll show you that in a bit. And again, the lot number can be literally anything the sender would like. Specifies how old the test is, but not how old the seed is. And it provides all the information we talked about. Again, if certified, it shows the MSGA certification number, and that ties back to all kinds of other verification information. It's why we're really big proponents of buying certified seed. Okay, we've already reviewed germination and viability, but let's review them again just quickly since this can be a little bit confusing. The viability analysis provides information on seed germination, including germination likely under favorable conditions, percent dormancy, and that's typically seed that needs some type of pre-treatment before germination will occur, and hard seed. And that's seed with seed coats that do not readily imbibe water and initiate the germination process. Those values are totaled together to give a viable percentage. And the viability is multiplied by purity to provide that PLS that we talked about earlier. The next section is purity analysis, and it identifies the species being tested, which is hopefully what the vendor indicated, indicates how much seed was used in the test, and provides 4 purity measures, all expressed as percent on a weight basis. So purity represents only whole seeds of the species being tested. Weed seed are seeds of species classified as weedy. Other crop seed, any seeds of species not the tested species, are classified as a weed, and then inert material, and that's everything not a seed. Some native grasses may have purities of 50 to 60% due to the awns or long seed appendages or just stuff you couldn't clean out. We call this trashiness. This trashiness can present handling problems and may limit how the material can be planted. So you want to look for this in seed reports when you're buying seed. It can be difficult to get through a drill, but at the very end, all 4 of these measures should total 100%. So again, you need the purity to calculate the PLS for determining seeding rates, and the purity indicates if trashiness may pose a seeding issue. So here's a good example that we often use. This is winter fat seed harvested. The one on the left is harvested right off the plant. And if you process it down through multiple operations, you can get it to what's called a naked utricle, and that's what the seed looks like on the right. You can buy seed in bulk and get a bag of fluff that looks just like the seed on the left if you're not careful. And then you actually have to clean it down to get it to flow through a drill. And here's, again, this is winter fat seed in various stages of cleaning. Actually, each one of these lots may have the same number of pure live seed. So this lot on the left is prior to any cleaning. This is right through the combine. The lot in the middle shows, some screening of large stems and other small things. And then the seed on the right is actually cleaned down to a usable form. So part of the purity analysis includes other crop seeds and weed seeds. And the lab report, not the seed label, specifies how many were found in the test sample and how many can be expected in a pound of seed. Since this detail is not found on the seed label, it makes having the lab report very important when selecting seed lots for purchase. This information is often very useful when determining the source of other crop seeds and weed seeds in a new seeding, and then defending the seed lot that was used. So what happens when a bunch of non-target crop seeds show up in a stand and they were not in the lab report of analysis? If you have the lab report in hand, you can defend that, it didn't come out of our seed because it wasn't in there. And it's why really we advise saving some seed back. Always save some seed and have the lab report of analysis in hand if there's a problem down the road. You can do a little detective work. So having the number and species of each weed allows buyers to determine if this is a lot they want to deal with down the road should the weeds establish. And here in this example, you can see this one has black medic and green foxtail and kochia. Some of these may be allowed, depending on whether it was certified or not. Do you really want to deal with these, or does a producer really want to deal with these? And how does it speak to our credibility if we didn't advise a landowner that these might be an issue down the road? So here's a simple example to demonstrate why having the lab report is important. So let's look at two reports from two different lots of antelope germplasm white prairie clover. If a vendor sold both lots and both lots had the amount of PLS seed you needed, which lot would you prefer? Even if the lab report on the left meets standards, wouldn't you prefer the lot on the right with, it's got less weed seed, less other crop, less seed dormancy, greater total seed viability, and a resultant greater PLS? So this is a good example of why it's important to have a lab report prior to buying seed. And if the vendor refuses to provide a lab report, and I don't think they're required to by law, I personally would find another vendor. I get suspicious of when they don't want to provide a lab report to the purchaser. So below the viability analysis section is the noxious weeds seed section, and it specifies the type and number of prohibited noxious weeds. And those are identified with a P, as in Paul, and restricted noxious weeds, and those are identified with an R, as in Robert, or simply restricted weed seeds found in the sample. This test can be specified for a single state. You can see on this report, it's for Montana. It could be specified for a region such as the West or for the entire US, and that's listed on the report as all. In a nutshell, I wouldn't purchase or use any seed lots with any noxious weeds. Prohibited, as in you can't have any, you just can't. Or even restricted noxious, which are allowed within limits by state. Again, reach out to the Montana Department of Ag and reference the Federal Seed Act, or call the Montana Seed Growers Association, or Monica or I, if you have a question or need help. So I'm going to talk briefly about certified seed, and I'm a huge proponent of certified seed. When you purchase certified seed, you automatically elevate the quality of the seed lot you're getting and reduce the amount of follow-up that is needed to ensure quality. Certified seed ensures the quality of the product and protects the buyer. It provides third-party verification for seed collectors and growers. Seed origin and generation is verified. Production fields are inspected to verify isolation distances and identify weeds, and seed cleaning facilities are inspected. If all the standards are met, only then can the seed lot be labeled certified. Certified seed is highly recommended for conservation seedings. Its use ensures quality, which improves the chances of a successful planting. Requirements for the use of certified seed for cost-shared practices varies by state and practice, so be sure to check your state standards. So in Montana, and this is thanks to Monica, she pulled this information together. Certified seed is recommended for range planting, seed PS by 50 whenever available, and for critical area plantings, 342 when available. For forage and biomass plantings at CPS 512, it has verbiage in there about using the cultivars recommended in technical note MT46, but doesn't specifically recommend using certified seed. And then in Wyoming, range planting 550 encourages the use of certified seed, but it doesn't mention recommending certified seed in the forage and biomass planting or the critical area, the 512 or the 342. It sounds like the conservation practices are going to be updated in the next couple of years, at least in Montana. I don't know if that's nationwide. And Monica is going to work with discipline leads to encourage the use of certified seed. Speaking to quality, this is an easy way to elevate the quality of our seed. Seed certification covers both cultivars and pre-varietal releases, and then there's different colored tags to indicate what class of seed is in the bag. For improved conservation species, the most commonly available classes are certified, source ID'd, and selected. And most all introduced grasses, some native grasses too, and then most all the legumes are at the cultivar level. And that means they have a lot of background testing and are pretty stable and uniform. Pre-varietal releases are commonly native species with varying amounts of testing. And in the case of source ID material, they have very little testing. Selected class material has undergone modest testing and usually only for a few years in a single generation. And then the tested class really has undergone rigorous testing and nearly qualifies as cultivar status. So again, seed certification protects both the buyer and the seller of seeds. And basically, in other words, you get what you pay for. Just to clarify, common seed is non-certified seed. If you cannot obtain certified seed, you may have to purchase common seed, but I always say buyer beware. You may not be getting what you paid for. Law requires that you still receive a seed tag, and especially when purchasing common seed, I'd request a seed analysis report. So in review, I just want to go over a few things, and this is just like practical advice related to seed labels and reports, procurement, and seeding in general. See the lab report of analysis for each seed lot before buying seed. And we covered why that's so important. Save each seed lot label and retain some seed, maybe 1 to 2 pounds. And this is a precaution that'll be helpful if a post-seeding problem arises. Buy certified seed. Certified seed is backed up by multiple steps, processes, and inspections, high quality standards, and other benefits not required with common seed. When possible, avoid common and variety not stated seed lots. They have no proven pedigree of performance or any of the benefits associated with certified seed. And then, be skeptical of statements like, oh, it's really Rosanna, it just wasn't inspected and certified this year. That's kind of sketchy. That's a little bit risky. Make sure seed test dates are current, especially for short-lived species like forage kochia and winter fat and sagebrush. And seed of forage kochia, for instance, as we discussed, has an especially short shelf life. Okay. Always, of course, work with reputable agricultural seed dealers, and most are. We're very fortunate in Montana and Wyoming. We have really good producers, seed growers, and then folks that sell seed. So we're very lucky. And then always buy on a POS basis, not a bulk. Don't assume that when you call and ask for 10 pounds of Rosanna, you're speaking about 10 POS. A lot of folks deal on a bulk basis. Okay, so until our next webinar, I want to leave you with the following resources. So here are some useful references regarding seed quality and labeling. We hope you take the time to look at these. This presentation will be available on the Montana, Wyoming Plant Materials website in each state's SharePoint under Ecological Sciences /Plant Materials. Remember that we do have another webinar that's coming up in May on seeding calculations. That's typically really well liked and well used. So please be aware of that. And then just if you have any questions, we have a few minutes. I'd be glad to try to answer those for you.